Okay, well, welcome everyone to the first class in our Home Energy in Alaska series. We are so excited to welcome you here tonight from all corners of the state of Alaska and to launch this fall series. My name is Mindy O'Neill. I'm the Executive Director of the Cold Climate Housing Research Center. And we do have a few upcoming seminars coming up, just for your information, on the topics of heat pumps for builders and homeowners, heat pumps for realtors, and solar PV for homeowners. And you can find information on those classes at our website, cchrc.org/classes. We'd like to take a moment now just to thank our sponsors, GVEA, Alaska Housing Finance Corporation, Southeast Conference, and Solarize Fairbanks. Because of the generous support from our sponsors, all our classes are provided free of charge, and when applicable, we offer CEU credits. Also, special thanks to the teams who helped put this series together: Information Insights, the National Renewable Energy Lab, and Alaska Heat Smart. We wanted to take just a brief minute to tell you about a new initiative that will help fund energy upgrades for nonprofits in the state. As a pilot project launched from the Solarize Fairbanks effort, Solarize Bright helps raise money for nonprofit organizations to upgrade their buildings to be more energy efficient. If you appreciate these classes that are being offered and would like to help see nonprofits become more energy efficient, please consider donate to Solarize Bright today. And if you'd like more information, an official launch will be hosted virtually this Thursday, October 13th from 5:30 to 7:30 or 6:30. Just scan the code on the slide. Okay, now a bit for some housekeeping. Tonight's presentation is loaded with great information. We'll be holding all questions until the end, but please feel free to pop them into the chat during the presentation and we will have someone monitoring that. We want to value your time tonight and end on time. So if we do not get to your question, we will provide them to the speaker to respond individually. Videos, you're welcome to leave your video on or turn them off. But if there are any bandwidth issues, which we don't expect, we would just request videos be turned off. And before I introduce our speaker this evening, we just invite you to participate in the intro poll that should have popped up to your screen. We really appreciate this information as we hone in on what topics are important to Alaska and where you are calling from. So now for our speaker for this evening, Emmett Leffel. He is a co-founder or co-owner of Alaska Thermal Imaging, LLC, or ATI, which specializes in building envelope testing and building diagnostics in cold and coastal climates. ATI has practical experience pinpointing causes of existing conditions and building enclosure system failure in everything from hospitals, natatoriums, and multifamily housing projects from the Southeast to the interior of Alaska that require whole building air leakage testing and building enclosure commissioning with thermography. Emmett's various projects include energy performance goals and owners' expectations of durable construction for new and existing building enclosures. His education and certifications are many, but of note include AHFC Certified Bees Rater, BPI Building Analyst Professional, and Healthy Homes Evaluator licensed Healthy Homes Evaluator, and he's also a licensed plumber and mechanical contractor. Again, thanks for being here tonight. We appreciate your attendance, your questions, and your interest, and I will turn it over to Emmett.
Thank you, Mindy. Can everybody hear me okay? Does it sound pretty good? Great. I'm just gonna move. I'm gonna move to the next slide, maybe. There we go. Thank you, Mindy. Let's start off with what this presentation will cover and where I come from as far as some of my training and experience. One of the things I want to get across to everybody here is where you can find resources, because I can't tell you how to weatherize your house in 2 hours, but I can show you where to find information that will help you identify problem areas and make improvements. And so a lot of the stuff will be information and training that the experts get, that the experts use for references and so forth. And so that's my sole goal, is to try and share this information. So some of this training I've gone through, whether it was Lead for Homes training that I've been through, or ResNet training, BPI, Building Performance Institute. And so that's where and through research of my own for customers, I found a lot of this stuff. And so the focus of any weatherization project should focus on comfort, healthy, durability, and performance. Those are key elements in an energy efficient home that are important. And when you don't have all three sides of those, then you don't necessarily have an energy efficient home. And we have three things we can typically do with any improvement. We can reduce energy use, right? We can turn down the thermostat. We can improve areas. We can add insulation and so forth. We can air seal, and we can make upgrades to systems. And obviously it gets more expensive as we go there. Right. So one of the biggest, I wanted to share this slide from energysaver.gov. It's a great website. It's a great resource, and we'll look at some of those if we have time. But space heating is such a big part of energy use in a home. And this is a national survey done by them. So cooling could easily in Alaska could be added to the space heating, just to give emphasis. And water heating is a big factor, right? And so we're looking for energy efficiency savings. Water, we cannot ignore water heating. And then there's some others, and then lighting and refrigeration, and so forth. But so energysaver.gov. And we'll jump right into the building envelope. That's when I test. And so we focus on the thermal envelope and the air barrier envelope as two different envelopes that have to align. And so this is from a Montana Energy Code reference guide, which is a great resource. In Alaska, you can find information on the Building Energy Efficiency Standard, and you can find that on Alaska Housing's webpage. But this Montana had a great energy code reference guide. It was helpful for just to look up things for homeowners. It's a free resource. But their front cover for of this reference guide focused on this amazing drawing, very simple. It shows the thermal yellow and the red lines being the air barrier, and it's important for people as they're going through and looking for areas of inefficiency. You have to start looking for these gaps and these air leakage pathways around chimneys and soffits and plumbing walls where we don't have a continuous air barrier. That's where you're going to have problems. And so I thought this picture would be helpful to visualize that when you're looking at your house. But we'll go into further detail there. Insulating, sometimes insulating can be difficult in some areas, but air sealing is oftentimes cost effective. Looks like my internet connection is unstable. Mindy, don't be afraid to jump in if I lose connection.
Okay,
so,
we heard you. We're hearing
okay,
you. Okay, it goes in and out just a little bit.
Okay. And so EnergyStar.gov has an amazing sections in it for insulating and air sealing. Where you can start to focus in on rooms and focus in on areas that are important to your house. And what I tell people oftentimes is to focus on, if we're focusing on comfort, right, as an issue or concern, you'll know where the areas are coldest, right? And you have, whether it's around a fireplace, I've seen that in living rooms because lots of air leakage, or in an upstairs bedroom where you may not have enough insulation. And so those comfort areas that you know about already are the keys to making your home more energy efficient. That's what I listen to as an expert when I come into your home and do an energy audit. Those are the areas, that's what I'm looking for, is any information that you know about your house, any complaints, any concerns, and those could be health concerns, durability. So if we focus on those areas, I found that even if things aren't cost effective, we can start to take care of 2 or 3 different problems in one improvement. And examples of that could be comfort downstairs, where you have a large stack effect in a house like this. We have a lot of cold air coming in downstairs and a lot of hot air going out. And so it's important to capture those issues. And so there's lots of resources out there that people aren't aware of. And so the Building American Solution Center, I'll show you a site there that's very helpful for guides and resources. And then of course, Energy Star. And Energy Star just isn't appliances. That's probably what they're most known for by people, but they have a lot of resources, and I'll show you some of those. There's another resource from Building Technology Program. It has an air leakage guide, and these are things that you're, as a homeowner, if you're making improvements to your house or hiring a contractor, these are the areas you want to start looking for. And there's guides that'll show you how to seal these areas and so forth. And the even if you hire an expert to come in and show you energy efficiency improvements, these resources can be valuable to make the improvements, right? Even if you hire a contractor, knowing what that contractor is doing and making sure that everything's being implemented that's effective will be extremely helpful. Soffits, how to seal and where to seal. That's the key information that you're going to be looking for, and I'll show you where you can find that. Yeah, and so this is one of my favorite websites. I can actually show you a section. I'll show you a section. This is one of the most useful websites I found for homeowners. And I just wanted to show you, because it has descriptions, scope of work, success, climate, training, even compliance sections where you can go into code. A lot of you may not be interested in that, but if you're talking to a contractor, sometimes we have to learn their language to be able to communicate with them, and then what success might look like. And so they talk about even training. They'll have videos and tutorials on how to seal certain sections of the building envelope. And so when we're going through whether it's a list of improvements from an energy audit, or we're going through a checklist, and I'll show you some checklists. I have some of those in here as well. This website, the Building America Solution Center, has been enormously helpful at some of those resources. And so definitely worth checking out if you're planning on doing improvements, and looking through their resources and programs and guides. It's I use it all the time. And this is another one here. This is not a common program in Alaska, but it's common throughout the States, and it's common in Canada as well, because it's been so effective at making homes more energy efficient. And so I oftentimes recommend this to contractors and experts. This is a resource that experts are going to be using to go through a house, whether it's new construction or a deeper retrofit. They're going to be going through and finding areas in a house that you can seal up, right? Walls behind showers and tubs, walls behind fireplace. And some of this might be Greek, right? What is an attic knee wall? But the amazing thing about this checklist, it actually comes with a rater's checklist guide, right? And so now we're using tools that the experts are using. And I first saw this through some training for Lead for Homes, ResNet to use it. A lot of times the ResNet ratings will use this. And so it's an amazing tool. It's still available. It's still fully, the website's fully functional. And the other nice thing about this is when you start to see language, which Energy Star Thermal Enclosure System Rater Checklist, when you start seeing some of this language, now we can start to search YouTube. And I have to admit, anytime I do something, whether it's repair my furnace or change something on my truck, I go to YouTube. And that's where I figure out what don't I know, and can I handle this project on my own? And I think that's what a lot of times what homeowners and people that are looking to do some of these improvements, there's a lot of people have the wrong perception, I think, that they can't handle it, that they need to hire a contractor. And that might very well be true, but there's a lot of things, there's a lot of homework that can be done to make sure you're hiring the right contractor and making the right improvements too. And of course, an energy auditor will come in and do some testing and show you what's wrong, and show you where you can start to save money. But so these resources can be extremely valuable. The Thermal Rater Checklist Guidebook, it has pictures. It's amazing. I use it all the time for referencing how to air seal an attic knee wall, how to seal up a staircase wall. And so it's definitely worth spending some time if you're doing any sort of deep retrofit or building a new construction. Strongly recommended. And so air sealing, like I said, is a very effective. And I wanted to talk about air changes per hour, because some of this is Greek to a lot of homeowners, and so we don't know what is tight, right? We don't know if our house is tight for one, and the best way to do that is to have a blower test done, which is something it's typical on an energy audit of your home, so it can be very valuable to do that. But even if you don't go that route, you just want to start doing some improvements, you can start focusing on floors, walls, and ceilings. And this may seem ambiguous, but if we start to look at some of these resources, we can find areas and what to seal, and I'll spend some time on that. Duct work is ducts. If you have a forced air system, if your ductworks hasn't been cleaned in 10 years, it's a great improvement. Duct sealing is super effective. Even if whether your ductwork is located in an attic, which is somewhat rare in Alaska, but even if it's located in a crawl space, duct sealing is very effective at improving indoor air quality, reducing energy use, and improving comfort in the house. It's a big one. Fireplaces, plumbing penetrations, doors, windows, those are all effective. And the IR picture it's a crawl space with crawl space vents, and you can kind of see the impact of some of that cold air in a crawl space. It's just thermal imaging is just, it's interesting to look at, right? More than anything. And so energy.gov is another great website that has some great resources, right? When we're looking at where to seal up, if you're a homeowner and you have no idea, but you know your energy bills are too high, these sites you can start to look at where to seal up, how to do it yourself projects, weather stripping, double hung sash windows is one that I hold up as a resource. But so we can start to implement these improvements, whether we're doing it ourselves or hiring a contractor. This information is needed because oftentimes, I'll tell you, a lot of contractors, some have a lot of experience and some may not have as much experience. And so these resources can be helpful. That can be handed to a contractor even, and worked with. One of our sponsors has, and this, all of our sponsors, quite frankly, when I went through and looked at our sponsors, it was a huge list, a great list of supporters here. And Cold Climate has some great tools, some amazing research. These websites are worth going to. And if you're looking at doing windows, you can find a calculator for window replacements. And you can start inputting areas, window values, and cost, and find out whether it's payback, right? In this example, this is a typical small home. 80-year payback is really long. And this is why when I'm doing energy audits, and it's really important to find out where comfort problems are, so we can fix two problems, right? Maybe we're just changing out two windows versus all of them. And we can look at air sealing some of the windows versus replacing them, because sometimes it's not cost effective. But if we can solve a durability issue, whether it's a condensation problem or whatnot. And so I've got a picture here of a window application. This homeowner, we did some air leakage testing and some thermal imaging and mapped out where the air leakage was coming in. And this specific window had a lot of air leakage. And come to find out later, the homeowner told me the window was only attached by some finish nails. That's what was holding this window in, and seems crazy. But so one of the big improvements, and this is from the Building America Solutions Center, right? We have a great detail, and I threw in the blue arrows because that's where we found the air leakage was coming in. It was coming in around the window and down. This is a common leakage pathway, and so it's somewhat simple to seal up. Right, we just pull off the trim here. You can see my arrow, and fill the void between the window and the rough opening with some low expansion foam, and then put the trim back. So it can be really easy to do, and important to do if this window isn't completely attached, like in this case. And what's amazing about Alaska is we can see our problems, right? I mean, I say something that's, it's hard to believe sometimes, but so thermal imaging, I can see a lot of these signatures in a thermal scale and thermal image, what I've found is you can see everything I can see thermal imaging, you can see with your visual eyes, right? You can see visually as long as the conditions are right, right? In the middle of winter, you can see this attic knee wall is full of frost. There's frost on the attic. That's easy to see. In the middle of, in Fairbanks climate, you can see frost showing up on the outside of your building. And so you can visually see these conditions under certain conditions. Thermal imaging, I can see them anytime, as long as I can create the condition. And in this picture on the bottom right is exactly what it would look like thermally, right? Over time, the water is deteriorated, the cedar siding, I believe that's, and so, yeah, and so the bottom left picture is kind of important. One of the things we see a lot is attic bypasses and air leakage into the attic spaces or a roofing system. And when you see this kind of frost coming out of a gable vent, that's a serious problem. People don't think it is. Even a little bit of frost, I think it's not that big of a deal. What they don't realize is the attic's full of frost. And what you're just seeing is the tail end of it. And after time, this gable vent will freeze over. And I've seen gable walls 2 inches thick of frost in Fairbanks, Alaska. And so it starts coming out the bottom at the eave of the attic, the bottom of the attic near the eave. That's because the whole attic is starting to fill up with frost to the roofing. As the top right picture, you start to see the frost showing up on the roof. And so I think this is the big idea that I wanted to get across in this presentation. Is you can see your problems in a house. You can start to figure out where those areas of concern are and zero down in on those improvements that need to be done. It's just a little bit of investigation, a little bit of work. And you'll get to that point where like, I don't know if I need to hire an expert, and you'll figure that out as you go. If nothing else, you'll be able to find options. And so when we get into an attic space, it's such an important area to make sure we got right. But we find large openings sometimes. And this is whether you have fiberglass or cellulose, you can start to see signs. And in this example, you see dark staining on fiberglass. That's the air coming out of your house filtering through the fiberglass. So that's actually the air quality coming out of your house, if you can believe that. But that's over time. And so these areas can be simple to find, especially if we have guides, especially if we have checklists, if we have YouTube videos and different websites that we've talked about, and I'll show you. And then on the top right picture, just for reference, it's a gable wall that's starting to ice up, and it's because it's the coldest surface. And sometimes you get an attic where it's got enough heat coming into it from an opening in the ceiling that it's condensating. It's not quite freezing because it's warmed up in the attic enough, and you'll get a lot of frost built up over time on that break wall. And so these are areas that we need to fix, because obviously the durability is not good here. We're going to cause a lot of problems over time, and we'll have problems with the roofing. We have water coming into the house. You'll have ice damming, so forth. And so EnergyStar.gov campaign to seal insulating attic air sealing project. These are the tutorials. These are the tutorials that some of the experts are using to reference and to train with. And so these areas, these pictures are so demonstrative. But whether you have a loft with the floor joist wide open, these are a big potential air leakage pathway. Attic hatches are notorious, and recessed lights, leakage around a chimney is very common. Soffits are some of the biggest air leakage pathways as well. At least potentially. And so these are areas we can find in our house, and we can go through and we can start, whether we're doing the work ourselves or hiring a contractor, we can get them sealed up. One of the things I recommend too, if you're hiring a contractor and they're doing air sealing work in the attic, get them to take pictures, because you may not have been able to go up there, but get them to take pictures before and after, so you know what they've sealed and you got a good idea. And then if your contractor has a blowout order, a before and after test can be really demonstrative to the impact, the effect, right? Were they effective in their work? Some of the thermal images, air leakage around a light fixture in the ceiling, attic hatch. I'm sorry, I want to go back. So the attic hatch, I've got lots of windows open here. So the attic hatch has got air leakage at the top there. That's cold air coming in. I'm depressurizing the house and taking thermal images. And here's a wall at the top right corner. That's there's a loft upstairs and a set of stairs that go up there. And that wall communicates with the ceiling, right? Just to give it some perspective on how we're getting air leakage from our house into the roof, and how this air leakage pathway contributes to a durability issue and a comfort issue. And then even rim joist sections, we'll look at that next. So energystar.gov is a great place to start. They've got a lot of tutorials. There's and it's also where you see Energy Star checklist and the guide. And so, okay, so this one is a video that I wanted to show you. It's a great website, and it's another huge resource. And I'm running out of room. Okay, so we just so construction instruction. It's a great website. I don't mind playing this real quick because it's only 40 seconds. And
earlier in this training, we talked about the importance of air sealing. Band joists can be a significant point of air leakage and heat loss. The band joist is a part of the floor framing that sits on the building foundation or between upper floors. For a successful Grade 1 installation, the joints between the foundation and walls should be sealed. Spaces created where the flooring and wall frame meet should be insulated and completely and securely fill the space.
Super simple video, but one of the things about construction instruction is they actually they've teamed up with they've had an amazing team. They do a lot of training, a lot of building science information, and but they've teamed up with manufacturers, and so they have a lot of publications with information, bathroom fans, how it should not necessarily how it should be vented, but you can find information about different resources, different building materials, different systems. And so it's a great, they've got a building science library. And so it's a great resource for you. Construction instruction. I'm sorry here. Yeah. So if you're looking for improvements, that could be a resource for you as well. And so the attic bypasses and ice damming conditions are a real problem. We've seen them in Fairbanks, depending on the time of the year and how bad the winter is. It's a bigger problem in Anchorage because of their climate. There's just warmer, and so there's more time for the snow to melt. There's less of that cold dilution air you get in Fairbanks. But oftentimes, and I wanted to point this out, there's looking at your roof and trying to figure out if you have a problem. The best time to do that is this time of year. When you get that first frost or that first heavy snow, you can find these problems. You don't even have to hire an expert. These show up black and white. You have dried out, thawed out roof, and you have frost all the way around it. That's a heat signature. And so now we know that there's a spot there that has a lot of air leakage or an insulation problem, and we can go through and you can hire somebody to go into the attic. You can hire an expert to come in and find the air leakage and what needs to be sealed up. In this case, there was one of the attic bypasses where air leakage was coming from the house into the roof was around the chimney chase. That's a really common one. And it primarily is caused by there's no rigid air barrier on the ceiling plane above the chase for the fireplace. And this is a problem in brand new construction today, potentially too. And in my opinion, I think it's because we don't use enough checklists and inspections to catch this stuff. We're relying on air leakage tests at final to find it, and that's not always effective. So even in this house, it had 18 inches of insulation, but it still had significant ice damming conditions and because of the attic bypasses. And that's what I found through diagnostic testing is a lot of times if you have ice damming or floor frost in Fairbanks when it's 30 below, these problems aren't caused by insulation. You might hire an insulator to come in and look at it, and they'll tell you need more insulation, and that might be true, but but it's not always. It's oftentimes it's the attic bypasses. I'd almost want to say 90% of the time it's air leakage causing these problems, and we know how to fix that. Right? There's resources out there to fix that. And so when we look at insulation, one of the best advice I can tell you is insulation. Even if you had an R19 fiberglass bat in your ceiling, you'd need more, obviously. Yeah, they're recommending today to be anywhere from R50 to R60, depending on your climate, right? So Fairbanks is a climate zone 8, Anchorage is more of a climate zone 7. But insulation, while it's important, it's the last thing you do in the attic. That's my big tip for tonight, probably for attic insulation. It's the last thing you want to do in an attic. There's air sealing improvements that are critical up there, right? We can have bathroom fan upgrades, and there's joints need to be taped up. We need to make sure this bathroom fan's venting properly. All of this tedious work to go through and fix these problems, right? This is actually a bathroom fan connecting to the roof and that's leaking by in the attic. You can see the hoarfrost coming off of it and the water damage to that roofing. These problems we want to fix before we add insulation up there, because otherwise it's so difficult to get to. So we just need to have an inspection of that area before we add insulation. And so insulation's last, and then sealing up the attic hatch is after that. Over the years, I've found so many problems in an attic space, right? And these are horrible pictures to imagine, but the bathroom fans that are just venting to the attic is a common thing, right? These plastic vents, they become disconnected or never were vented potentially. And so even though this foil flex can be problematic, it can fill up with water because it's cold and condensing. It can disconnect because of just the weight of the water and ice. Or you could have dryer vents. I've seen in a couple of cases, dryer vents venting right to the attic. Plumbing vents that are leaking or venting to the attic. And so those definitely are a priority because those are serious durability issues. And so adding insulation just isn't a priority compared to that. And then we get into worst case scenarios where we have heating ducts running through an attic space. Those are a big problem, and they're hard to diagnose, right? And so oftentimes we can go through and we can take a look at them. They're hard to get to, they're hard to see. An expert would be able to do some duct leakage testing or some differential pressure testing where they're finding cold air coming in through one of them and can pinpoint where some of the problems are. But if you have ductwork in your attic in Alaska, you want to look to move those. You want to look to redesign your HVAC system to try and find a different way to heat your house. This is a cheaper option, but it's oftentimes it costs you in the long run. And we end up with, when you have forced air duct leakage running, pressurizing an attic or depressurizing an attic, or the opposite's happening in your house. You're pressurizing or depressurizing. And the same thing can be happening at crawl space, right? When you have duct leakage, you could be pressurizing or depressurizing a space, a garage, and so duct leakage is critical. And so the Energy Star campaign to seal up ductwork has been super effective. A lot of great resources, and so this is a picture of a forced air system in an attic, and that's not common. This is more of an Arizona house. But I think I've maybe seen one in the last 14 years doing energy audits to see an HVAC system in the attic. But regardless, like I said, if you have an HVAC system in your crawl space and it's doing some of this, it's leaking this much air, you're going to have, oftentimes you'll have a pressurization of that crawl space and a depressurization of the house, which can cause problems with combustion safety and or other problems with draftiness and cold comfort. So duct sealing is super effective. There's I don't know if I can open that or not. Yeah. But and so when we have a ductwork, it's in an attic, it'll be insulated. It's harder to see. It's harder to seal. The products are a little bit different and it's problematic. And so you might have to hire an expert to go in and make repairs or look for redesigning, like I said. But in a crawl space, like I said, the same thing can happen, and the ductwork is just as important there. And this is new construction pictures. These are all what you might find on new construction, and so it's a real problem. The codes require that it to be sealed, but sometimes it just doesn't get sealed as much as it needs to. And so these are visual, you can see this type of leakage. You'll see dust prints and dust streaks on top of the ductwork that you can go through and seal as you're working through a crawl space to make these improvements. And cracks and joints and connections, they're all going to leak. And so we look for any ductwork, whether it's in a garage or a crawl space. You can start to visualize from this picture where these joints are and how you can seal them. And you can use a duct sealant that you paint on with a brush, or you can use foil tape. Don't use duct tape. Yeah, duct tape is not for duct joints. Super important ductworks sealant if you have them. I'm running ahead of schedule. This is good. And so filtration is super important. Did I skip one? No, I didn't. Okay, we're good. So filtration is super important. It has a big impact on your energy use for a forced air system. And so it's not only important to keep your furnace clean and running efficiently, but also to keep your house dust-free as much as possible. And so filters can be important. And oftentimes you find at the store, you find a 1-inch filter with a MERV 8, and that's the minimum. And it actually creates, that filter type can create quite a bit of restriction. And so this bigger filter looks like it could be even more restrictive, but it's not. It has more surface area for airflow to go through. And so you can get better MERV ratings and a better filtering and better airflow, which allows your furnace to run more efficiently and also heat up. It doesn't have to work as hard to heat up your house. And so bigger filters can be an improvement and a simple thing to do. They're harder to find though, I found. And so Energy Stars, it has some great recommendations. Well, some of the research I found effective is obviously just changing your filter, tuning up your heating system equipment yearly. And they have checklists. I mean, this is the important part. I could tell you that you need to tune up your furnace and you might go and hire a contractor, but finding these resources on what can be done, a checklist, and making sure that your contractor that you're hiring is doing everything on the checklist is important. Tedious at times with contractors maybe, but it's effective, right? And so the other improvements, even finding contractors with 10 tips to finding the right contractor can be helpful sometimes. Programmable thermostats, they can be super simple and they can be somewhat more difficult. You'll have to see if this is something you can do yourself. Like I said, a YouTube video would be extremely helpful to figure that out. But it's oftentimes the biggest, quickest payback. Anytime you get an energy audit, a list of improvements, they're going to tell you, oftentimes if you don't have one already, it can save you quite a bit of money with a simple install. The ducts, we talked about that, considering installing Energy Star qualified heating equipment. So in Energy Star's webpage, they actually have a list of appliances. So now we can start to compare manufacturer to manufacturer a little bit, and then we can start to dig into which products. And sometimes that's tedious for homeowners to go through. We rely a lot on our contractors, but oftentimes their contractors just relying on what's on the shelf. And so if we want to upgrade, we want an improvement, we have to do a little bit of homework. And then proper installation of new equipment, right? Replacing old heating equipment with new energy efficient models is a great start. Improper installation can reduce efficiency by up to 30%, according to Energy Star. And I think that's probably most key with forced air systems, right? When you have ductwork that's not sealed, ductwork that's running through an attic or whatnot, these are big impacts to energy efficiency. And so heating systems are, and I think I missed a few pages. I want to go back. I think we have time here. I wanted to look on Windows. We talked about Windows and calculators. I'm sorry, guys. I got in a rush there maybe. But so Windows and wall insulation. I wish I could get rid of that, but let's go this way. And so Windows and so we saw the calculator at Cold Climate's web page. They've got and this Alaska Heat Smart. They've got a lot of resources here for information. These energy audits and installers, electrician, heat pump maintenance, great website for information. Window calculators can be useful, but they also have other, there's NRELs, there we are. So they've got calculators in here. And so a lot of times people don't realize these are here. And if we go to whether we're looking for domestic hot water improvements or HRV efficiency calculators, the other Wisdom Associates has similar. This is another local training provider here in Alaska. They do energy audits, inspections, great company, great family-owned company. They have a lot of great calculators that people can use that people aren't aware of, and other resources, whether it's for lead and other resource presentations, boiler safety, and so forth, ice dams. And so when you're looking for information, these websites are available. This is Wisdom Associates. They've got calculators for ventilation calculators for if you're trying to decide how much ventilation you need in your house, and you don't want to, maybe you can't afford an energy rater, or you can't have one in your area. This information is available, and even Alaska Housing's webpage has information on ventilation sizing. So there's information available, and so that was something. And so attic air sealing. Let's look at this page. It's got, this is from Energy Star, and so they've got some information you can go through and look for tools and materials, what it's going to take, and for a homeowner, this is how you decide, can I do this? You know, find a YouTube video. Is this something I can handle, or do I want to hire this out? Sealing behind window, door trim. We were just talking about that. So amazing information. Some of this information is better than what you'll find from an energy rater, to be honest. And I can speak honestly because I am one. But so this information will help you just make the improvements, find the locations that are in your house. If you've got a comfort issue in your basement, we have some bedrooms. You could look at those windows as for air sealing, and the rim joists, and Analysis North, right? This is one website that I wanted to point out because a lot of the professionals in Alaska use Actform, and this is a free download. A lot of people don't realize that. And so if you wanted to utilize this tool, and to input improvements, I love when people hire me to come in and do this for them, but this is something you can actually play with yourself, and it's not that hard to go through and make some. They come with sample energy audits. You can get copies of your energy audit from your rater or from Alaska Housing if you've already had one done, and so you can start looking at doing improvements there. And then this is Alaska Heat Smart, great. Yeah, so yeah, I wanted to cover some of that stuff because so often I can't tell you how to fix your house, but I can show you the information where you can start to make better decisions on how to fix this stuff and who to hire. I just thought that was. And so ductworks, we talked about that. Filters, improvements, heating systems. Heating systems, forced air, we talked about some of those improvements that you can do with forced air. One of the big improvements you can do with forced air system is if you've got an older furnace and you're making improvements. So say if you have a contractor coming in, it's like, yeah, this furnace fan motor has to be replaced. Talk to them about upgrades, right? And so there's a website I found for doing research on this. It's furnace upgrades with ECM and PSC motors from hpacmag.com. And it goes into a whole explanation, what's effective, what's not. And you can start to look at, because these motors can start to save you a lot of money with older fans, and they can be cheaper than replacing the whole unit. Sometimes tedious, I'll give you that for sure. And then duct sealing, we talked about that, how the improvements can really tighten up your system and improve comfort, durability, and indoor air quality. And then a filter replacement, of course. So boilers are a little bit different, right? The boiler is circulating hot water through your house and through a water heater maybe. And so there's pump upgrades as well for that. The manufacturers are claiming 80% electrical savings with the smart pumps. And these smart pumps balance flow and pressure and temperature sometimes. And so there's upgrades for that. And this can have an improvement in your system performance as well, even versus a pump that's moving water too fast or too slow, we can start to balance that system based on pressure or flow. And so those smart upgrades are simple for typically a contractor would do, but if you're handy, you could figure this out. It's a YouTube thing for me. Control upgrades, they do make smart controls where you're monitoring outdoor temperatures. So it's a big recommendation we see in boiler systems, especially oil-fired. And so outdoor reset controls and controls, and a lot of the newer boilers already have these internally, especially gas appliances. But some of the oil-fired boilers and older appliances don't. And so these are great upgrades. They tend to cost anywhere from a couple $100 to $1,000, depending if you're hiring a contractor or doing it yourself. And then, cleaning your baseboards, it seems redundant, but it can be effective if you have a lot of pets and so forth. And then insulating your pipes in your crawl space and mechanical rooms. What happens is your boiler just doesn't have to run as long. It's pretty effective. DOE energy savers recommendations for older-fired appliances, right? So these are some of the recommendations that are come up in an energy audit. And but actually, barometric fluid damper doesn't come up often. It's not a primary improvement. It's not an upgrade option, but it's something that can be easily done. It's something that should be maintained. And I should be pulling up a barometric damper so you can see it. You see what I'm talking about if you're not familiar with it. But if you have an oil-fired boiler, you're going to be looking at it every time we look at the boiler, typically. And I just want to show a picture so people can see. And so this is a barometric damper. It's made by Fields Control, and these things wear out, right? They pivot on a swing point. The barometric pressures inside the chimney are pulling flue gases up the chimney and opening up that damper when the boiler heats up, and they just wear out. And not every year, but just typically over a 5-year period, you might see a wearing out of this, and it just won't open or close. You can even see some corrosion developing, and so they also need to be balanced. And sometimes that's an expert needs to typically do that. They'll balance that based on how much draft over the fire they want. And so these things can have a big impact on how much heat's going up through the chimney, and how much energy we're wasting. Derating oil burners on a boiler is something that it gets some attention. We don't see it in a recommendation in an improvement options report. Oftentimes, if you're having an energy audit, a report for you, they're going to say you need to replace your boiler or you need to add a control. But you can derate the oil burners. It's really more of a trained professional that needs to do this type of work, because they have to use combustion analyzers and then reset up the combustion process to make sure there's enough air being injected into the boiler with the oil, so we have proper flame. And but there's advantages to doing this. It has to be done per manufacturer's recommendations for the size of the nozzle that's going to be downsized to. So it's definitely a trained professional. And then modulating aquastats. We'll take a break here in a few minutes, but I'll keep going. But modulating aquastats, like I was talking about controllers, right? They're outdoor reset controllers. And this was just pulled from energy.gov, their energy saver campaign. And so you might not remember some of these details, but we can go to this website and find more information. And it looks like there's a YouTube here related to barometric dampeners for information. The heating fuel comparison calculator, I wanted to throw this in. It's been really useful in areas where people are looking at converting and they don't know if they're going to save money. It looks like it's a good deal, and sometimes it is. But this is a calculator I found online about a decade ago, and I've been using it since to help people make decisions on upgrades, right? If you're changing a boiler, right now I think this is a big deal in Fairbanks, and in Homer it was a big deal a little while ago, and there might still be some people making upgrades there. And so if you've got an old-fired boiler and it's running at 87%, and in Fairbanks it's 489 right now, you're paying about $40 per million BTUs. And so if you're looking at changing to natural gas in Fairbanks, it's 209. per cubic feet and CCFs. And so if you're able to upgrade that appliance to 95%, you're going to be paying about $22 per million BTUs. And so we're almost half, right? It's a big improvement, especially with this price of oil. And then, but if you were to upgrade your burner on that oil-fired boiler, upgrade it to a natural gas burner, then your appliance is running at 80% and you're paying about $26 per million BTUs. And so that can be helpful information if you're trying to make a decision to spend quite a bit of money to upgrade and to install gas into your house, but it's worth it. It's worth it. And so I wanted to share that. And so this is just a heat calc from Burkholder's that's been really useful. It's probably a good time for a break. If you want to take 5 minutes or so, we're just ahead of schedule. And so if everybody wants to take a break, I can answer questions too. If
that's great. Griffin, or sorry, Emmett.
No, it's fine.
So let's take a break until 6:30.
Okay.
And we'll start back at 6:30. Okay.
Perfect. Yeah. The windows. Somebody had asked if there was the window replacement payback calculator was through Cold Climate's resource page. Right here. I think that's what you were talking about. Miss Joe Woodward had a question about that. Let's see if Wisdom has it. So there was a question about windows. I'm not sure how many are still on here, 25. But there was a question about windows. There's that calculator at CoClimate's website. And then Building America Solution Center has a great section in for building envelopes, and windows are one of them. So we actually have right and wrong images, a few. And I'm sure Energy Star has something. There we go, right there. The project step-by-step guide. Great question. So Miss Jo Woodward has a great question here. She's asking about a better way to insulate around windows than using foam. You know what, I've seen, it's almost 6:30, most people are back by now. So I've seen a few cases, mostly in commercial applications, where they'll use a backer rod and insulation, and that can be effective, right? We can caulk surfaces, we can seal from the outside to make sure it's weatherproof, and then backer rod can be effective. But typically in residential, it is all foam. Yeah, it's this all day long. And you can see here in the picture, you've got window and door foam sealants, right? And so this is another great website. I've actually gone to Handyman several times looking for details and work. And so another great website inside of EnergyStar.gov. Yeah, so foam is typically is best practice in residential, but you can do backer rod. And backer rod is just a rubberized foam. It typically comes in a round, like a round shape, right? So it can be easily, if you have the right size, you can tuck it in between the windows and fill that gap with that, right? And then add fiberglass as well to help insulate. Okay, that answers that question. Mindy, are you on? Do you want me to get started? Is everybody ready?
Yeah, let's do it.
Okay, so most of you probably have seen this if you're stuck around, if you took a break. We looked at some windows. There was a great question from one of the participants to how to seal a window, and that's just an excellent question, right? And so we went to Energy Star. It's got some great tutorials on how to seal and insulate, and this is better information you're going to get from an expert, quite frankly. This is the how-to and what you should be looking at, even if you hire a contractor. And then it gets into basement crawl space air sealing, attic insulation, sealing behind windows and doors, and applying plastic over window projects. This is something I've done in Fairbanks. And so if you've got no other choice, and this is not a bad option. And so I definitely, if you've got nothing else to do, you can do that for sure, because windows are expensive. And the window calculator is a nice little tool. Acworm can help you calculate whether a window is worth replacing if you have all that information to input. Otherwise, you can use these simple calculators. And so I think there was a question. I have time, so I want to make sure. Barometric dampeners, right? A great point here by Gary Newman. They have safety issues for sure. I think I have a picture in here where you kind of see what's happening, or what can happen with soot and carbon buildup and so forth. And so, great point. Definitely need it though. You need a barometric damper. You know, if your stack is high enough, it's almost necessary per the manufacturer's recommendations, because we have to control the draft over the fire, so we can't get rid of them. Yeah, and so water heaters are a big percentage of our energy use, and oftentimes there's a lot of things we can do besides just replacing the water heater, which is a standard recommendation. You're going to get an energy audit. So energy.gov has got some simple language. It talks about the energy efficiency, energy factor, and we measure energy in a water heater a little bit different. And a boiler you might, or furnace, you might have an annual fuel utilization efficiency, AFUE. In water heaters, it's energy factor. So when you're in energystar.gov site looking at water heaters, you want to compare an energy factor, which is a decimal, like a 0.8 or 0.9. Electric would be a I think 9.8 or higher, even though it's more expensive to heat. But so we can reduce, right? Obviously, we can use less hot water. And I have teenagers, so I've put low flow faucets and shower heads everywhere I can. And we can buy more efficient models, right? We're making those upgrades, those expensive upgrades. If you're making improvements like an upgrade, it's best to do it. It's most cost effective, at least, to do it when you are replacing an appliance, right? There's an extra cost. It's a little bit more, but you're making that upgrade at the end of a life cycle. And so you're not throwing away a water heater that's 5 years old or trading it out. You're actually replacing a water heater that's failed, and you're upgrading it to a higher efficient model. And there's real improvements that can be made from water heaters. You might have a combustion safety problem depending on the appliance type you have. You might have problems with cold sandwiches. They call it cold and hot water fixture problems. And so there's potential to fix a lot of problems and comfort issues. But we can fix leaks, right? We can reduce this stuff. We can look at Energy Star appliances, and we can follow the manufacturer's recommendations, which is important to my next point. The next point, not this point, sorry. So tempering valves are something that's never going to show up on an improvement options report. It is something that should be recommended though, because these things are a T where they have hot water. You can see in this thermal image, they have hot water mixing with cold water, and that's going to your toilets. And you can see in this toilet, took a snapped a picture of a thermal of a toilet, and we're just flushing. These appliances fail. When the tempering valves fail, you start flushing hot water, and it's really uncomfortable. And so I'm just got an internet connection. Sorry. And so these improvements here, the tempering valve can fix all sorts of problems, right? With water comfort issues where you're getting cold water and hot water, cold water, and somebody flushes the toilet and you get a cold flush in your shower. That's caused almost always by these tempering valves. And so you can look around for these, get these replaced. And they come from the 1980s, maybe the 1970s too, I'm not sure, but they are trying to fix, with a tempering valve, they're trying to fix the condensation problem that happens on tanks in the toilet where you have a bathroom with too much humidity. And what I found is if you have too much humidity in a bathroom, it's because you don't have enough ventilation, right? If your mirror is fogging up, you don't have enough ventilation in a bathroom. Those are simple telltales that are important, right? And so tempering valves, we should get rid of. Everyone in Alaska no house should have one. in my opinion. They cause nothing but problems, right? And so we can fix leaky pipes and faucets. A faucet dripping is a lot of money, it turns out, and it adds up over time. And so one of the things I've noticed too with water systems, if you have lots of leaky faucets and the house is getting older, oftentimes it's a water softener is what you really need. They can actually fix those problems where you're not building up calcium and other deposits in the shower valves and then the faucets. And so a great resource is WaterSense. It comes from the EPA. You can typically find it through Energy Star or EPA.gov for WaterSense. And they've got a great program for faucets and showers, and it's a lead for homes type requirement for WaterSense, but it's tied to Energy Star too. So if you need resources for that, that's where you want to go for that. So hot water heater traps, right? This shows up in the manufacturer's literature, but rarely ever gets installed. And it's never going to show up. Maybe there's some great raters out there, but I've never seen it recommended typically on an improvement options report. But this is a simple piping configuration that's rarely done. And it, as a plumber, I oftentimes didn't look at it as well, I have to admit, but what I found was the customers telling me about stories about how they were able to cut their electric bill in half. They had electric water heater downstairs in the basement. They had hot water piping going all the way upstairs to the 3rd floor. And inside the hot water piping is convection, right? You have convection inside the tank. That's what the arrows show. But you also have hot water convecting up through the pipe, and it can, because it's bleeding through the shower valve. The valve's off, but it's circulating water through the shower valve and back down. And so we get that natural convection through the piping 24/7, 365 days. But a simple trap, and this picture from the manufacturer shows a 6-inch minimum, but 6 to 9 inches is great. And it's a simple piping change out. There's also tempering valves you can add in to help improve comfort and make sure that your water's safe. So these improvements can save you lots of money if you have that type of configuration where your piping's going straight up into an upper floor, which is common. And here's some thermal image of a hot water it's a natural gas hot water. I've thermally tuned it so it's kind of thermal image inside of a digital picture. And so it's reflecting some of the heat off the piping and the water heater. And you can see the convection going up through the pipes. And so heat traps are important. Hot water demand systems are a circulating system inside a house, and not every house has this, and not every house needs a hot water on demand type system where it's kind of confusing with the language, but it's a hot water circulating system that circulates hot water to your fixture, right? So you're not waiting a minute for hot water or 2 minutes in some cases. And it oftentimes I find these pumps are just set up to run continuously, and the piping isn't insulated. Those are big problems. And so oftentimes this doesn't even show up in an improvement options report from MacWarm if you had an energy audit done, right? But these are important improvements, right? The energy codes tell us we need to insulate these piping. And not until, I don't know what year that started, but going back for a long time, these pipes were never insulated. They thought, well, it's just heat to the house. It's, we have mostly cold most of the year, but it's really inefficient. And and so it ends up with being very wasteful. So insulating your hot water pipes is very effective. If you have a ranch style home or a long distance and you're waiting a long time to get domestic hot water to that fixture, you can do a recirc pump. They can be effective, and you can incorporate remote receivers or hard buttons, and you can look at pumps that control based on a time or a thermostat control, right? And so those are effective, because now these controls are turning off this pump when it's not needed, right? We can manually turn it on with switches, like in the other example, or we can have it set up on a timer so it's ready to go when we get up in the morning. And so these can be a problem where they use too much energy, but they can also solve problems and reduce energy and reduce water usage too. And then tank and pipe insulation, right? We talked a little bit about piping insulation, but this was a YouTube video I found on tanks, whether you should be insulating or not. It's a great resource. This old house has got some amazing videos, and they're great to watch. And so there are some water heaters that you don't want to add insulation. It gets confusing. And what I found is you get older water heaters that you can add insulation to safely, but they're old enough you should be looking at replacing them. It's time. Yeah, and so we're getting to a point in the industry where adding insulation to the outside of a tank really isn't a smart move, and most manufacturers don't recommend it because newer appliances, even going back 10, 20 years, you get enough insulation on that it's a problem. So, but this is a nice helpful tutorial on when and where you can add that. So, and then exhaust ventilation. I want to make sure there's no questions that popped up. But so exhaust ventilation is important, and it as we tighten up the house, we need to replace that natural ventilation that we used to have through the attic or through windows. We need to replace that with mechanical ventilation. And the old fans, they may not have worked well. They may not have been vented properly. We saw some of those pictures in the attic. The ductwork was just falling apart or didn't go vent to the outside. And so these are things we can look for, right? As a homeowner, if your mirror fog's up better than I do as an expert that's coming in and helping you. And so if that's an immediate flag. If you have a mirror fogging up, you might look at replacing your bathroom fans. And if you have a bathroom fan, look for the damper outside. Does it open all the way? And what I found is oftentimes they can be painted shut. They can be they can have bees nests, which is crazy to find, right? And a basement bathroom where you pull out the ductwork, this old flex ducting that's not effective. It was completely clogged off and blocked because of a bees nest. And I've had homeowners that I've helped test and identify problems where they 10 years ago they had their house painted, and since then they haven't had any ventilation. So these are things we can check, right? Does that damper open all the way? Where is it located? Is it on the roof? Is it functioning properly? And so sometimes you have to hire an expert to look at that. But if you can get up on the roof and check, you can basically leave the fan running and check it. And that can be super effective. That's what the rater is going to be doing, making sure you have good ventilation there. And they have equipment to test it, right? But if it's, so we don't have to get but in this example, we have 70 to 100 watts for an old fan that wasn't working well, not vented properly. And so a new Panasonic fan or something equivalent would be using somewhere around 17 to 24 watts with that ECM motor, which is a more efficient fan motor that you could get for your furnace as well. But so there's smaller fans in this, they just use a lot less electricity. They're using around 17 to 24, yeah. And controls are amazing on ventilation because we can reduce the on time. The newer Panasonic fans, that was in that informational on construction instruction they had, plug and play modules. I can pull that up so we have time. And I might be able to pull it up. I have to go back. There it is. Shoot. And so the Panasonic fans, I'm not trying to sell you one today, but it's oftentimes you have plug and play modules. We don't necessarily need to watch this right now. You guys can check this out. And Panasonic has guides too, honestly. If you go to the manufacturer's webpage, they actually have a guide on a catalog of different fans. And there's a ton of information in there on how they should be installed, what wiring configuration, and some of that may be Greek to you, but you get an idea of what's required to install the fan, how it should be installed, and you can talk to your contractor about what they're going to do, because that's what I found. I mean, if you are working with an expert, whether it's a lawyer or energy rater or contractor, sometimes you have to know their job as well as they do in order to get your full value. And so we'd have to do a little research. Yeah, so check your bathroom fan, check your dampers, make sure they're opening up, make sure your fans are moving air. If you have an older fan and you can't replace it, you can do timers. Like a 30-minute timer can be effective with an older fan that's only moving maybe 30 or 40 CFM. And then you can plan in long term for making improvements. There's upgrades to those, of course, an HRV or an ERV, heat recovery ventilation or energy recovery ventilation. These are sometimes the best thing you can do to a house. They get really expensive, but we're bringing fresh air in and we're recovering exhaust. And the Serve is a newer product online. It uses a heat source pump or an air source pump to recover heat through the exhaust and then pump it in. So it actually can start heating a little bit, which is amazing. And so it's a big unit, it's expensive, it's a lot to install, but it can be a big upgrade too. Sometimes when you're looking at tightening up your house, you need to replace that, like I said, that natural ventilation with mechanical. And then Wisdom Associates has got a great little calculator as far as heat recovery ventilation cost estimator, so you can find out how much it's going to cost to run. Yeah, if you have these appliances, oftentimes maintaining them is the biggest thing you can do, right? If you have an HRV in your house already, cleaning the filters and cores is the heat exchanger core, that is, and the intake screens are some of the most important things. When I do inspections, I oftentimes find intake screens clogged and something not balanced and not performing. And so having that service regularly and learning how to do it or how often it should do, you can find it in your manufacturer's literature. And you can obviously find the ductwork outside and make sure these screens are clean. That's a simple thing to do. Combustion safety is so important in a house, and it's something that the integrator is going to, it's definitely part of their scope. It's definitely part of their assessment to make sure that your house is not able to backdraft a combustion appliance. And so there are tutorials there's information about this stuff. Some of it gets very technical, and that's oftentimes why it's important to have an expert. But once you see what they're doing, it's pretty simple, right? We're just looking for any spillage of combustion gases. It could be out of, number two is a water heater and a furnace tied together, right? And so if you have flue gases spilling into that room when you have the kitchen fan on, you can feel that, right? And we can get carbon monoxide detectors. It's important to make sure we're in safe environments. But if you, and we'll go over that too. But so it's not uncommon to see, even in a tight house, I see a wood stove backdrafting a water heater. Those combinations are possible. You could have multiple bathroom fans on and backdrafting one of these appliances. And so we have to be careful of that. It's very important. And we could be pulling fumes from a garage where you parked a car. You could be pulling that into the house. It's another great place to seal if you're doing air sealing improvements, to find that rim joist section that ties into the garage, or any penetrations between the garage and the house. Sealing those up is really important to reduce that migration of garage contaminants. And so this oftentimes you can figure out yourself, but you might need an expert to help you come in and really figure out what's going on. And so oftentimes if you can find a problem, you can see if it's worth hiring an expert, right? A heating contractor or an energy auditor, depending on what you need. But these are some of the pictures, and there's a barometric damper right here. The top left, right, the pressurized, ended up being pressurized, the whole flue system, and it was because of a failure of a component downline. It was a side vented unit, and so the I'm sorry. So there's actually a video on Cool Climate's webpage talking about this appliance. It's kind of informational about combustion safety. So again, Cool Climate's a great resource for different research and different aspects of the components. But if you're seeing the sooting, and one of the questions was about this, right? If you're seeing this, that's a problem, right? If you have a unit heater like this, it's a gas appliance. If you're seeing a darken like that, a stain, or if you're smelling some heavy gases, that's a problem. You want to look for that. And oftentimes it's because the appliance is improperly vented, or like I just had before, I'm sorry, I jumped around on you guys, sorry. Oftentimes we were just talking about this, right? If we're running a kitchen fan and we could be depressurizing this heating appliance in the garage or downstairs in the basement, you don't know until an alarm goes off if you have one set up. And so we want to look for these signs. Anytime you have a chimney outside like this, it's a flag for concern, a red flag, I'll say. Long horizontal sections and short rises, that's a risk where you're going to have low draft and a potential to backdraft that appliance. And so oftentimes we want to upgrade these to sealed combustion wherever we can, where we can afford to, and we want to make sure they have enough combustion air, where we're allowing free air to come into the combustion zone. So let's go to the next page. And so this was a pretty interesting case. I had a homeowner in Anchorage that had a gas-fired boiler, and we did some testing during the energy audit and found a low draft condition, even under normal conditions. And I think the house, if I remember right, is quite a few years ago, but house was very leaky, but they still had low draft conditions. They actually didn't, I wasn't able to backdraft it because the house had so much air leakage, but because of this large hole, they had low draft. And so when they went to replace the boiler, they found this large opening, and these are the things you find when you start to dig into it, right? When you start to replace stuff. But and so I think that was, yeah. You don't know until we start testing it. That's a big part of that. Ovens and ventilation, right, are so important. And Berkeley Labs, the Lawrence Berkeley National Laboratory, did some research on these on ovens and gas appliances, electric as well. And they found that the ventilation really isn't effective. And and this is something else we'll test during an energy audit. But if your dampener outside on a kitchen fan isn't opening up completely, you may not have enough ventilation, and so there may be a problem there. But even with a properly operating fan over a kitchen oven, there's problems with indoor air quality, and it's kind of interesting. So one of the statements I found in this research paper was that if these were, so they found that a significant portion of residents exceeded outdoor air quality standards for several pollutants on a weekly basis as a result of cooking with a gas burner inside their house. If these conditions were outdoors, the EPA, Environmental Protection Agency, would be cracking down, right? This is what they said in their presentation. But since it's in people's homes, there's no regulation requiring anyone to fix it, right? And so reducing people's exposure to pollutants from gas stoves should be a public health priority. And it's important. People don't perceive it as important because they feel comfortable cooking in their house. And so ventilation is important. And so one of the things I found useful in identifying these conditions, right? So an energy auditor will have a combustion analyzer, and he or she will test how much CO is coming out of this appliance and whether the room's safe. But you could do this yourself. You don't need an expensive energy auditor. You can basically have a digital CO detector. And so I recommend digital CO detectors for every customer, because it helps you identify problems where normal CO detector or fire alarm won't, right? And so it's good to have those. They recommend them, one on each floor. You can have them fire and CO. But oftentimes a digital CO detector is extremely useful because it's not uncommon. And this was an example down on the left there. I walked into somebody's boiler room and they had no idea. There was no alarm history that they were aware of, but they had almost 500 parts. And I've seen people with 1,000 parts not have any awareness of that risk. And this is a high risk situation when you're having this level of CO in any part of the house. And so a digital CO detector will help you identify whether you have a problem sometimes. And you can test the peak levels. This brand also has gas alarms. If you have natural gas you're bringing into the house, you just want to make sure you're safe. You can get these dual sensors where gas and carbon monoxide. And so I came up with this solution, and this is how you can help identify whether your home is safe from carbon monoxide. And you can place it. People ask me, where do I put it? And if you have normal CO detectors with your fire alarms, you can put it anywhere, right? So you should want to have one per floor near the bedrooms. But if you're working in a garage, it's not a bad idea to make sure that space is safe and have a digital CO detector. If you're in the kitchen cooking, a digital CO detector can be really helpful identifying low-level conditions that occur every time you cook. And so I check it as often as you need to, as much as you want to. Put it where you can see it. And you can call an energy rater if you have problems start to show up and you don't know what's causing it. They can help find that out. But also, you can call 911 if you're in the middle of an alarm, of course. Right? Makes sense. And so wood stoves are another source for carbon monoxide. They're a great way to heat a house. They do have a lot of air quality concerns with them, and so we have to be careful of that. And so if If you've got a wood stove, I always recommend outside air. Bringing outside, it's part of the code requirements. It's typically a manufacturer recommendation or sometimes a requirement in certain cases. Some contractors don't like to install the outside air directly into the wood stove, but it's effective. And also you can make sure that your wood stove is installed airtight, right? Cementing the stack and making sure that all the seals are working well. I've had a couple cases, one in particular in Fairbanks, where a radon system was backdrafting the wood stove and causing some seriously high CL levels. And it's because the wood stove is the only combustion appliance you typically see in a house that doesn't have a steady state burn, a clean fire, right? Because it's heating up and cooling off. And so CL levels is definitely a concern with wood stoves. Not only can it backdraft other combustion appliances in the house because it creates that negative pressure, but also it can be backdrafted. And so and air quality is important. An electric bill, Golden Valley is a supporter here. They helped make this class happen. So I use their source. If you have a different electrical company, they have sources. There's a smart hub feature. I'll show that next, I think, or one after that. But so you have customer charges, utility charges, fuel and purchase power, regulatory charges, right? So it's sometimes important for people to realize what exactly they're paying and how much they're paying. And so when we look at electric bill, your usage is detailed out in the bill, your meter number and stuff like that. These are honestly what energy raters might look at, especially in commercial applications. They want to make sure that this is the right meter. We got accurate readings and everything looks good. I wish my electric bill was this low, but and so one of the things that can be really useful is if we're monitoring our electrical usage, we can start to identify problems and fix them quickly. And so Smart Hub is something that was advertised an MEA, and it's a great site. I believe you can do this with almost any electrical provider, and you can do it with others as well. I found out doing some research on this, you can use other utilities can be added into Smart Hub, and so it's extremely useful. You can look at daily usage and monthly usage, and I mean, here was mine. I wanted to paste it in here just to show a comparison, because a lot of times I hear of customers that have really high electric bills. I mean, so this is kilowatt hours, and sometimes I see people with 2,000 kilowatt hours. It's really extensive. And so, I mean, just to give a perspective for people, 800 kilowatt hours is typically average. And I happen to have, my November and December is a little high because I have some outdoor pets that I heat and provide water for. And so but I have, just a comparison, if you don't know if your electric is high or not, I have quite a few TVs in my house, several freezers, several refrigerators, forced air furnace. But my electric bills, I'm still able to keep them down in that 600 kilowatt hours to 800 kilowatt hours on a normal basis. And so if yours is much higher than that, there's some improvements, and I try and cover some of that stuff here. One of the best resources I found for lighting, and lighting, remember, is a fairly small percentage of your energy use, maybe more so in Alaska because of the darkness and the amount of daylight we get, how little we get. But so one of the great resources I've found over the years, and this is fairly old resource, it comes from the Forest Service, and it goes back to the basics, and has a lot of great details and information on the different types of lighting, the different colors of lighting, and the lumens and efficacy of the different light fixtures and bulbs. And so I wanted to list it here because it goes over the different power and energy definitions, voltage time amperage equals watts. And that can be a lot of science for some people that aren't used to reading on this. And so this resource really goes back through and helps you calculate what your energy bills are and how you can start to save money. And so 1,000 watts times an hour is a kilowatt hour, which equals in Fairbanks 28 cents. The other big source it has is a simple format where you can calculate your energy use, so it helps you to understand what you're saving and how much you're saving. It goes into temperature of lighting, which I think is important. The lighting is one of the great improvements you can do to a house, because you can actually transform a house, right? You can transform living areas in your space by doing these upgrades, and they tend to have a good payback. You'll find you can start to save pretty good bit of money for the investment you have to do. And like I said, you can really start to improve quality of life in a house with lighting upgrades. Controls, right? So when we're looking for electricity and lighting, oftentimes, even ventilation, right? If we can reduce the on time, we can really start to save money. And so these are simple improvements. And so timers are effective, of course, for vehicle plugins. Bathroom ventilation works well for an older fan. And then spotlighting for lamps and so forth. Sometimes we can put timers on those. Dimmers are great, not only for mood lighting, but changing the atmosphere, but also reducing the energy costs. And photocells are great for outdoor lighting, right? If you're upgrading light fixtures outside, there are a lot of new products on the line over the last 10 years that have LEDs, and they have daylight photocells and timers and motion sensors, and those can be super effective for outdoor lighting. Especially, it seems like some of the older outdoor lighting was high wattage, and so those are probably your biggest savings. And then motion sensors can be controversial. Some people don't like them, but they can work well in a garage sometimes, laundry rooms, closets, and so forth. Appliances there's some savings in appliances, and sometimes, depending on how old your appliance is, newer appliances can start to pay for themselves over time. You can start to see real savings, and sometimes, but it's confusing on how much to save. So energy.gov has put together some resources there, and you can obviously, a lot of us have seen an energy guide, right? We've seen the energy guide here. We recognize that on almost all appliances now, even furnaces and so forth. One of the things I wanted to point out in energy guides labels here are oftentimes you have to look in the fine print to see this energy label is for it's calculated at 10 cents per kilowatt hour, and so we're almost 3 times that in Fairbanks, probably twice that in other areas, and so this would be a little bit misleading, and so don't get caught off guard by that. But when we're trying to figure out what appliances to replace, we can calculate how much is being used. We can use electricity usage monitors, and I'll show you some of that. We can calculate annual energy consumption and cost using formulas, and there's actually, I wasn't planning on this, but there's actually new sections in ACWARM, right? And so if you can get this information, you can, if you're comfortable with working with, it's got a great help section too, but you actually can start to look at lights and appliances, and you can itemize inputs. You can hire an energy rater to do this for you, where we're going through and looking at each appliance, or you can do this stuff yourself. It's pretty simple, trust me. And so that can be effective for calculating energy consumption and figuring out what appliances to replace. And then one of my favorites, and that I try and recommend as much as possible, is install whole house energy monitoring systems, because just like when I'm trying to track my weight and I weigh myself as often as I can, right? But if you're doing that with your house energy, you can save there also. And so it's just as effective. And so let me go to that. Energy Star appliances. Every appliance has 2 price tags, right? And so what we pay for it, and then how much it runs. And so EnergyStar.gov has a list of products that you can do some research on if you can find appliances. Now, I think they're fairly hard. And then monitoring your energy, right? This is actually one of the best tools you can use, especially if you're one of those people that have really high kilowatt hours on a monthly basis, right? If you're having that usage problem and your bills are $300-400, these tools can help you identify the problems better sometimes than an energy rater, better sometimes than an electrician, I've found, because an energy rater has a limited amount of experience identifying some of those problems. And electricians, they understand the problems, but I found that they have a hard time finding it. You'll need their help. You'll need an expert's help eventually. But oftentimes, if you can get this installed, whether you're installing yourself or have somebody that can help you, because these oftentimes these bigger monitors here, the Nereo and the current cost, you have to install a clamp onto your electrical wires inside your panel. So it's important to hire an expert when you're doing that. But some of these kilowatt meters, this is an older system. It works great. You can find it at the hardware store or at a library even. And even this Belkin model was really nice. It's got a wire, so it's easy to measure refrigerators and stuff and other appliances, and you can input the cost you have per kilowatt hour and so forth. TED Pro is an older system, but great. And so these can be really helpful identifying, especially when you're looking at clamping on, you're measuring your well and you're measuring how much energy is used by your forced air system, your freezer, or a bigger appliance that you want to try and track. You can start to see, is this appliance efficient, or should I be upgrading it? Or is there another problem, right? If my electric bill is 2,000 kilowatt hours and I'm only measuring 900, there's a discrepancy there. We need to look closer at that problem and see if there's something else. So that can be really useful. And electrical, it just comes down to turning off some stuff, right? Everybody knows to put a timer. It's extremely effective on you have several vehicles plugging in. It's a lot of wattage. And so vampires or phantom appliances use electricity even when they're off, right? Because they're in standby mode. And so what I found is these are really useful for TVs, and I have my kids trained to turn off a switch if when they leave the gaming room, right? And turning off TVs, and even sometimes a computer, but oftentimes you want to have a computer on sleep. But so these we use a conserve socket. It's a timing feature. We've used it on lighting for kids when they're going to bed, and the conserve power is great for those appliances in the kitchen when you just want to have them turned off, like a coffee pot or toaster. And then we already looked at the how to monitor with some of these. I've even for fish tank, right? You can have different things turning off and on, and so that can be really effective at saving money with some of those appliances. And so these aren't huge loads, right? We're looking at, for an average house, this is an older website. I wish it was still going, but I couldn't find it again. But they had an annual vampire energy cost calculator. And so I went through for my house to figure out what I was using, and we got an estimate of about $150 for vampire load. And so a lot of these things we can be turning off. A printer can be turned off if you're not using it. A stereo, of course, could be on a switch, just like a TV. Like I said, I have a gaming room where everything's turned off as soon as they walk out of the room. And so everything's off. TV, all the gaming, or any other devices that got plugged in. And so there's potential savings there in your house. One of the other loads, it's big. Some people have a well, some people don't. Some people are hooked up into a city and don't have to worry about this. This is a bigger system. This is on a community well, but it's a decent picture. And so we have components here that can break down. Wells can be a huge load on a house, and so sometimes we have to. This is something we can monitor, or we can have just inspected if you don't want to hook up an energy monitor for your whole house and different components in there. But oftentimes the well pump will get clogged up and it'll start running all continuously or longer. You can have wires that start to wear. You can have bad connections, right? That can start using a lot more electricity than normal. And so we want to look for that stuff. And the energy monitor installed on the house will identify these concerns and motivate you towards getting a well person to come in and inspect and replace any components that are breaking down. And there's upgrades too. And this doesn't typically show up on an energy audit. That's why I wanted to bring it up tonight, but there's constant pressure pumps. If you have these systems that can help reduce the high amp loads from on-off appliances. And there's other unknown other loads, right? And so we have jacuzzi, security system, heat trace, right? Insulation's much cheaper in the long run. And we can put timers on stuff. We can keep things off until we need them. But faulty wiring and breakers, anything that's warm is hot, or hot is using power. And so we want to fix that stuff where we can. And sometimes that takes, obviously that would take an expert, but you can start to find stuff with that energy monitoring system installed on your electrical system. And then, like I said, I have outdoor pets, but some people don't. And so these are stations that you may not be able to change, but I've actually put timers on heat lamps. I've found thermostatic controls for heat lamps, and so there's products out there to help you maintain temperature versus just continuously heating all the time. And then holiday decorations, obviously timers are great for that, to make sure they get turned off so you don't have to remember. So again, we're just reducing, improving, and upgrading wherever applicable. One of the big things that it's not an energy aspect, but I wanted to throw it in here. If you're planning on doing weatherization, the EPA has a bulletin out for people to worry about if they have a house that's older than 1978, to be aware of potential lead, right? And so this would be an expert that would be called in. Wisdom Associates was a great website for that, and so Wisdom Associates had contractor EPA certified firm applications. They do a lot of training, and they would be able to help you find the right contractor or information. And the EPA would be the best place probably for information about this. But if you're making improvements in an older 1978, you need to find out if you have lead or not. Radon is something that's not talked about enough. And so I put it in here because it's something we all need to think about. And I found this older bulletin from the EPI. .Alaska, and it's amazing how high some of these levels were being found in areas that, for people that don't think they have a problem, right? The Matsu Valley doesn't really perceive they have a problem, but some of the inspectors are telling me, yeah, there's some numbers out there that are high enough to be worried about. And so educating yourself about radon is important. If you're making improvements, sometimes this won't be brought up enough, and so you need to be aware of it and making sure that if you're going to be tightening up your house, are we making this problem worse or better? And the best part about radon is in the past, it was somewhat hard to get equipment to test for this. You had to hire an expert to come out and test. Today, we can actually set up a sensor in the house that will connect with your phone and tell you what levels are. You can have a little standby station that will monitor levels, just very similar to what a CO detector, digital CO detector would do. And so we can start to identify, are levels higher than they should be, and do we need to take action, right? Anything over 4 picoliters, and we have to make improvements there because it's too high, and it's one of the leading causes of cancer. So definitely don't forget about this as you're making improvements. And one of the things I recommend, and especially before you make improvements, is start to monitor things, right? There's a lot we can monitor in a house besides the temperature, right? Radon is there's a simple device that they can monitor that. There's the radon eye, and there's another one that I'll show you a picture of. But so we want to measure for radon, I think, in every house. If this was an option, just like CO detectors, if we were able to put a radon detector in every house, that would be probably the best thing we could do, honestly. But relative humidity is another thing we can monitor. It tells us how tight our house is sometimes, how much moisture is in the air. And relative humidity in an Arctic climate or a cold climate, we need to make sure that we're maintaining that in a safe range where we're not getting condensation and mold growth in other areas of the house that we can't necessarily see. Carbon monoxide, we talked about that, super important. Carbon dioxide is common in commercial applications, but it can be important in tight houses. And so that's not a bad metric. And then volatile organic compounds that comes from products like this desk here, right? It may be off-gassing organic compounds and the paint and the glues and so forth. And so that can be, I've actually had volatile organic compounds, VOC poisoning from doing inspections on a house. And so this is a real concern in any house, potentially. And so it's not a bad thing to measure. And then particulate matter is great. I mean, it's important to measure, in my opinion. It was a big problem in Fairbanks in the winters. And so if you've got a wood stove, you want to make sure your particulate matter is low and safe, or take steps to do that. And so EPA.gov is a great source for indoor air quality. And I might have a website here. It could be helpful just to reference. That's Hackworm. Sorry. Nope, that's Energy Star. Here we go. Indoor air quality, right? EPA's website, EPA Indoor Air Plus, is, like I said, associated with EnergyStar.gov too, and their programs. But it can be a great resource for information about improvements you can do, what levels, what you should be looking for, and what we can do to make our house have better indoor air quality as well. And so monitoring these metrics can be important in helping you identify problems, especially if you have asthma, right? That's a no-brainer. But oftentimes, what's interesting is in my own house, I've used to have a food bot. It's now outdated, and this model is not available. But it helped me identify indoor air quality problems, and I've had customers do the same thing, and go through and find problems. What oftentimes happens when you start to monitor particulate matters or radon or carbon monoxide is you start to change habits, right? We start to see a problem, we start to change habits, and it could be how we ventilate the kitchen when we cook, stuff like that. That was really an effective tool there. And so these are some of the older models. There was a evaluation done on some of these, and these were some of the best products. And some of these are a little bit outdated. You might be able to find some of them. But I think the food bots, it may have been revamped or discontinued. And so replacing it, we're finding newer products come online called the Wave Plus. And so it's reading multiple things: radon, CO2, humidity, temp, airborne chemicals, and pressure, right? And so we can find, and so this, I recommend this, I do, and these are cheap. I believe this is in the $200 range, or maybe a little bit more. And so it can be really helpful. And oftentimes when we're making a tighter house, the contaminants in the house are going to become more concentrated. And so the awareness of, are things getting worse or better, can be really helpful to make decisions after whether we need to increase ventilation, or we have a carbon monoxide problem, we need to call in an expert, or change how we use fans and windows to ventilate the house. And so, or upgrade appliances to sealed combustion. That's pretty much my presentation. I think we have some questions, and I want to make sure if I can answer them now, that would be great.
And Emmett, just so you know, I have some open questions in that doc they sent you. It looks like I've gotten everything so far.
Okay. You've captured all of those questions in there? Okay.
Mm-hmm. And everything everything that hasn't been answered is in yellow.
So I should try and click on that, huh?
Yep, it should work.
There it goes. Okay. Great. Yeah, great question about a dozen devices to monitor all of these different things, or a single product. I think we answered that, right? With one of the products being the Airwave Plus. I found that this is pretty user friendly in that effect, and it connects with your phone. So it's a phone app too. Very powerful, and then you can start to see things as they progress and change. And I've heard this from inspectors too. Even radon the radon levels can change, obviously different seasons, but also at different times of the day when you're running ventilation, you're depressurizing the house. The levels can get very bad and then go back to normal. And so that's oftentimes the eye-opening to people, because they have it tested, it's safe, but then they come in and we start looking at it with the monitor, and we're seeing changes, conditions where it's not safe, and so we can start to take action. Right, the radon detecting machines, Wave Air Plus, the Wave Plus, I think is probably one of the newest products online, but there are some others. The Radon Eye is another one that can connect to the. So Jay Rogan has a question. Radar detecting for my house, we got that one. Whole home energy monitoring device, sense.com. 300, but a great tool if one geeky enough. Great point. Thank you. So it's sense.com is, and I think that's current. It might be current. And so we looked at monitoring. I don't mind going back through this. I think it's one of the coolest things you can have in a house. And I've used this with people that had really high electric bills that they couldn't figure out, and it was we were able to figure it out with it. So the current cost is one. So sense.com is the other question. The other point that Jay Rogan brought up. Thank you. Or no, I'm sorry, that was somebody else. Okay. So if appliances are plugged into an outlet, they are drawing a vampire load unless you have them on a turned off power switch. Yes. Right. So if not all appliances, but many, right? My coffee pot, if it's plugged in and on, it's pulling power for a clock or something, right? And then TVs tend to draw more, and older TVs had a higher standby ratios where they had higher electrical use when they're off. And so they can be very effective just to power that off. You're not having to unplug it, you're just hitting a switch and it's turning everything off. And that's effective, yeah. And then how would you explain again how the person cut their electric bill in half during introduction on hot water heaters? That's a great question. That was a great, I've always appreciated that story because, so the water heater, they had a water heater, electric water heater downstairs in the basement, and it had to be a 3-story house, and it doesn't matter, it could be 2-story. I'm just gonna go back and find it. And so, I don't know if I need to, but I'll go back. Yeah, and so the heat trap would have fixed this problem for these homeowners, but they had hot water. There's a convection current that happens in hot water if it has an upward path, right? And so if you have a valve upstairs that's leaking by, you could have the tempering valve on a toilet that oftentimes leaks by, and so that's on an upper floor, and you'll have convection through that fixture, that valve or whatnot, and it'll circulate inside the piping, right? And so your electric water heater or gas or whatever is going to be trying to heat up that water constantly because it's conducting heat through the pipes and convecting through the pipes. And so they happen to, in this example, they happen to replace their shower valve and we're able to fix it that way with a new shower valve. But a heat trap would fix that problem. And it is a real problem. If you have a water heater that doesn't have a heat trap, and you have pipes that go up to the next floor up, you likely have convection, and this could be a nice energy savings, and you're just changing the piping to where it traps. Great question. And so, question on danger from gas, propane stove tops and ovens. Same with electric stoves. Great question. And I mentioned that, and I see, I'm sorry, I'm moving around too fast probably, but so with the stove, see if I can find it again. The research they found was it's not the same, right? You have a combustion appliance versus an electric. You might have the older electric coil, or you might have a flat plate electric oven, stove, and then you can have electric convection. The gas is going to be a higher, I'm going to go ahead and admit, the gas is going to produce a lot more combustion products and CO and other gases that come out of that, right? There's quite a few. But quite frankly, they found in this study that the electrical coils, the older electrical coils did off gas, right? They did produce some particulates into the air. And what I found doing with some research as well on pots and pans, right? The Teflons, they can really produce a lot of off gas. And I was reading on it the other day, they can actually, the people have had problems where their birds have died in their house because they were using a Teflon pan and they were cooking too hot with it, right? And so there's a lot of information about those on the internet. And propane ovens. When I talk to people, there's 3 sources of pollutants. The 3 biggest pollutant sources in a house are the garage, the crawl space, and the oven. And so if you have a gas or propane oven, it oftentimes can produce high levels of CO, and that's when you preheat cycle, you want to run ventilation on high, maybe have a window open. So we're purging that space and getting all those pollutants created by the oven during its preheat stage, and then you can turn it down to low once it's up to temperature. A lot of times, that's what we find when we test these appliances. But yeah, the CO detector is super helpful in this case. You wouldn't need a CO detector if you had an electric oven, but if you have a gas, you would. And so I think the answer is not as bad. Gas is worse than electric, but you can still have a lot of pollutants in a house. And in indoor air quality, VOCs and particulate matters could help you identify that. That's what's helped for me and other customers as well. And let's see if I may answer all the questions or if there's any others. I think there was a question early on that I didn't get to, and it was, how do we estimate solar gain? And I don't know that there's a good way to estimate solar gain. There's the ACRM takes it into consideration, and so there might be that aspect to it, of course. But if you were talking about windows, there's NFRC stickers that have solar heat gain coefficients. But other than that, solar gain is hard to calculate, and I haven't seen a calculator do that. I've seen it in thermal images. I can see how a wall will heat up once the sun comes out and heats it up. And so there is gain even through an R11 or R19 wall. You'll see some gain there. And obviously we get more through the windows, and that's where we see the solar heat gain coefficient. And that's an NFRC that you can, when you're researching windows, you can find that. And the Energy Star and the Building American Solution Center will help. Probably Energy Star, I would start there. Yeah. Was there any other questions? Okay, yeah, this is a great question about indoor air quality. What metrics you can measure. And sorry, I'm going through these. I'm just going down so you can have a list in front of you. Right, so radon, top of the list for me. Relative humidity, simple, you can do that with the weather station. Carbon monoxide, digital CO detector. Carbon dioxide is a digital CO detector. Right here is a CO2 monitor. Not typically, not considered to be a high priority, but I think it's important. And some of the wave, I think they measure CO2. And then VOCs, I think, are important. I can speak from experience. I've felt the poisoning effect of VOCs, and it's real. But and so, and oftentimes I'll explain this. I think we have a few more minutes. Oftentimes, you don't know you have a problem until you can start to associate a symptom with a metric reading, right? A CO or VOC reading. And that's the power of monitoring. It's the same thing with electrical monitoring when we're metering our electrical usage. But when you can identify, and I've done this through testing with CO and now VOCs and so forth, when you can measure something and see and feel the side effect, you can start to connect the dots there. And digital CO detectors can be life-changing. I have a few customers that have been able to identify this problem and realize the symptoms are vast, much larger than they would have ever imagined, and to where they were able to change their lives by correcting a few problems in their house. So definitely recommended. Anything else for a device like the Wave Plus? Assume that I'd need one for each level of the house. You know, the Wave Plus is really mobile. I don't know that I would. I don't know that you could spend as much as you wanted to and get one for each house of each level of the house. But you can move it around too, right? You can monitor one area for radon and then move it to another area. That's a simple way to do it. Thank you, Jay Rogan. Appreciate it. Thanks for being here. And what is recommended for relative humidity for a home? Great question. So our bodies want 50%. That's that's ideally healthy for our sinuses and our lungs. Our houses oftentimes can't really handle more than 35 to 40. And so you kind of have to split, kind of have to try and keep that down to 35. Some houses, and especially in Fairbanks, where you have much colder temperatures, you're going to be at 30% relative humidity. And so you'll find the first thing that condensate is probably the windows. And so you can start to, if you start to monitor relative humidity, you can start to identify how much, what can we get away with here? How can I change my habits in the house to lower the humidity naturally and create a balance there? Can I increase the ventilation to create a balance there? Keep the curtains open longer? And so those are simple tricks once you start monitoring those conditions. You're welcome. I think we've gotten all the questions answered. And I'm sorry, I just turned off that.
Emmett, thank you so much for such a great presentation. I learned a lot, and I need a list of all those links, those computer links for go through later.
Yeah, no, that's why I put them in the report presentation too. So I just realized people can gain a lot more from a resource like these versus me trying to tell them what they can do when I've never been in their house. And so Thank you, everybody, for being here. I really appreciate it. Looks like we had a lot of good feedback. And was there anything else, Mindy?
Yeah, if before you leave, if participants wouldn't mind just taking this exit poll, that helps us gauge the value of the class, and your comments are greatly appreciated.
Yeah, I think yeah, thank you, everybody. And if there's one thing you can take away is don't be afraid to tackle weatherization. You can do this. It's super simple. All right, thank you.
Awesome. Thank you. Bye, everyone.
Bye-bye.